Okay, so what we're doing here is we're looking at rationalising surds. So remember, we can't have a surd written at the bottom. So what we have to do is we have to have a integer at the bottom of a fraction and not a surd, and likewise here. So we've got to go through some steps. So if we've got this kind of scenario here, we've got a number and then we've got a surd at the bottom. We need to multiply that by a fraction of that surd over itself. So we're multiplying it by 1. Square root of b over the square root of b is 1, and so we're not actually changing the number, we're just changing what it looks like. And then we go through the steps there of multiplying surds. The next one, and then as well as that, so if we've got a plus here or a minus, remember, if we've got two terms, whatever the sign is here, we've got to do the opposite. So if we've got a plus, we've got a minus. If this was a minus, we'd have a plus. So we're going to have a look at that. So over here, we've got 3 over the square root of 2. Now, we want to multiply that by 1, except we multiply that by 1 in a special way, and that is a fraction of root 2 over root 2. So root 2 over root 2. Now that becomes 3 root 2 over square root of 2 squared, and that ends up being 3 root 2 over 2. And that's it. And if you're not sure, check it with your calculator. All you do in your calculator is you would enter this in. If you've got your CAS, it should convert it to this straight up. If you're just using a scientific calculator, you work that out, and then you work this out, and you'll see you end up with exactly the same answer. Okay, now on to this thing here. So for this, what we're going to do, we're going to move up a little bit higher. So with that, we've got 2 over 3 plus the square root of 2. Now, like we said, we've got to multiply that by 1, but we do that in a special way and multiply that by 3 minus root 2 over 3 minus root 2. So then from there, our next step, we end up with, so like we said in class, if we multiply fractions, multiply the top, we multiply the bottom. So over here, we'll have 2, and then we'll have 3 minus the square root of 2 over 3 plus root 2, 3 minus root 2. Okay, and then from there, we need a little bit more space. Let's look at this with the blackboard, or the whiteboard rather. So with that, what we're going to do, we are going to multiply the top line, so we'll end up with 2 times 3, which is 6. 2 times negative root 2, which is minus 2 root 2. Then we're going to multiply this bottom line. So we're going to have 3 and root 2. We're going to have 3 and negative root 2. So that's what we've got. That's what we're dealing with. So 3 times 3 is 9. 3 times root 2 is 3 root 2. 3 times negative root 2 is negative 3 root 2. And then negative root 2 times root 2, we get negative root 2 times 2. So from there, we collect like terms, simplify, and do everything else we need to do. So we'll have 9 plus 3 root 2 minus 3 root 2 minus root 4. 2 times 2 is 4. So from there, we'll have 9 plus 3 root 2 minus 3 root 2. They cancel out. They don't exist. They make 0. And we have minus the square root of 4, which is 2. So we're left with 7. So then we'll have 6 minus the square root of 2 root 2, 6 minus 2 root 2 over 7. So with that, they're the steps that we take. So with this, so if we just got a normal fraction, let's have a look. If we just got normal fraction, just a number on top, number on the bottom, we multiply them both by this number over itself as 1, and then we do the steps that we need to do. If we've got something with 2 terms at the bottom, like we do here, we then make it as it's the top number over the bottom times 3 minus root 2 over 3 minus root 2. So whatever the sign is here, we make this a fraction and opposite. And then from there, multiply the top line, multiply the bottom line. And this is where expanding binomials comes through, exercise 3D. So we set it up like this, and of course if you can do it quicker, you're welcome to. So once we expand it out, we'll find that this term and this term cancels. So that's what we should end up with. So we should have a number times by a number minus a number or plus a number, and we should end up with a number at the bottom. An integer plus an integer, rather than having any surds at the bottom. If you haven't done opposite signs, you will get a surd in the middle, and that's not what we want. So what we want whole number and a surd, whole number and a whole number, integer and integer, so we have an integer at the bottom. And then the steps we take to rationalise surds.